This is some actual 35mm film, the one that cinemas used to run before digital cinema took over around 2015. And this is a broken vintage computer. Now, these two items have something in common. What could that be? Let me thank today's sponsor PCBWay. Stay with me, we're gonna find out. Hello and welcome back to my channel. On the desk today I have a DTS XT10 cinema media player. This was used in cinemas when 35mm was around to play DTS soundtrack. If you've been to a cinema before more or less 1995 and you watched a film running in DTS, the Digital Theatre System sound, well, chances are the sound you were hearing in the auditorium was coming from one of these boxes. Everything we're talking about today is before digital cinema, before digital projectors came out and replaced the old 35mm projectors. This is when prints like this were being run through a mechanical projector and the sound was being read from the print itself. Now, as I said, this machine is broken, so we're going to try and fix it today. But before doing that, I think I'd like to give you an idea on how digital sound used to work on 35mm print, and in particular, how DTS sound used to work on film. Now that we have an understanding of how DTS works, let's take a look at this machine. I don't really know exactly what's wrong with it, but my goal today is to fix it and also try and make it as reliable as possible. These machines are going to be used for 70mm screenings, and on 70mm there is no backup track. So if this machine fails, well, the sound fails in the auditorium, which is not great. Now, besides the DTS boards, which are this one, and this one, everything else here is off-the-shelf components. The power supply, the DVDs, the hard drive, the motherboard, the CPU, the RAM. It's a vintage computer, around 2005, I think it is. In this case, we have an ASUS P5P800-VM motherboard. It's a socket 775, and I believe the processor, it's a Celeron or something like that. You don't need a huge amount of processing power for this machine. It's basically a Linux box getting the data from the hard drive and passing it to the decoding boards, which eventually they pass it to the output board here. Now, this machine was designed with three features in mind. Number one, play DTS sound, that's the basic one. Number two, play subtitles using a small digital projectors. Number three, playing some sort of alternative content like commercials through a small video projector. Now, the third option, the alternative content, I think it really never happened. So I think the board for that option is not even on this machine. But obviously the DTS digital sound and the subtitles, those actually worked. And this is what this box is being used nowadays when a 35 or 70mm print is being shown. There are three custom DTS boards on this machine. This one is the output board. It's getting the data from the system and turns into either analog output through this connector here or digital output through this connector here and this daughter board here, which I never seen before. It's the first time. It's a little addition, so you can also have digital output out of this board. This long board is the E622, is the one getting the time code from the projector, and this shorter one is the E494, also called the playback card. And I don't know exactly what's doing what, but I know that this one is doing the time code, is getting the time code from the projector, and I think between the two they also do the sound decoding that gets eventually transformed into analog or digital output through the output board here. These are two DVD-ROM drives, and under the drives we have the hard drive. Now, everything on this system is PATA, parallel ATA. And I'd like to swap the hard drive at the end, because obviously it's getting old and it's probably getting unreliable. And thankfully this motherboard is new enough to have two SATA ports. So I'll going to try and see if the software installed on the system is happy with the SATA drive instead of a PATA one. This is a standard DTX power supply. We'll have a look later on at the wattage and what type of power supply there is. And that's it. I think we might want to switch on this unit and see what it does, because I haven't really tested it. One peculiarity of this unit is that at the front panel, there is an on-off rocker switch. And as you know, this is an ATX board. It doesn't do on-off. It should have a push button and behave like a modern computer with ATX power supplies. But I guess DTS wanted the operators of these machines, the users of this machine, to just have to deal with an on-off switch. So this very motherboard has some sort of a little contraption going into the front panel of the motherboard itself. I'll show you later, but I can see that the on-off switch is going into that contraption, which is going onto the motherboard. And I guess it's translating the permanent contact closure of the switch into a pulse for the motherboard to wake it up and also to turn it off, because on a normal motherboard in ATX you have to push the button for several seconds. I don't know, but it's an interesting contraption. I think it has a PIC on it, so there must be some programming involved, some logic, very simple logic probably, and probably there is something on the software side as well. So enough me talking, let me plug this machine up. Let's wire the VGA output to my capture device. We'll turn it on and save a backup, because that will also save some licenses specifically for the subtitling system, which was an option when this machine was purchased. If the license is lost, DTS are not providing them anymore, so I can reformat, reinstall this machine, but without the option. So this is going to be a sound-only machine. Let's give mains to the machine. 3, 2, 1, go. I see a standby light on the motherboard, and let's turn it on. 3, 2, 1, go. Wow, that's noisy. And I don't think we have any output. The display here on the front is a USB thing, and it's not really doing anything until the machine is fully up and running and the driver is loaded. But I haven't got an output from the VGA of the motherboard itself. Let's take a quick look at the voltages. 12 volts is fine. One of the 5 volts, well, this should be power good, I think. This is 5 volts and it's fine. 3.3 is fine. And this is the standby voltage, which is also fine. So the power supply seems to be fine. Let's take a look. Let's remove this board here so we can get access to the motherboard. We'll see if there's anything wrong with it. Well, I think I found a problem. Well, this motherboard, I think, is from year 2000 and something, 2003, 2004. And this is when the capacitor plague was happening. And indeed, I see quite a few bulged capacitors. Some have barely leaked from the vent on the top, nothing horrible. I don't see anything wrong with the with leakage and corrosion or anything. But clearly, this motherboard will need to be recapped. So the first step for repairing this machine is to remove everything, take the motherboard out, and work on the motherboard. Once the motherboard is posting, well, then we can see what to do to make this machine better and more reliable. Let's take the motherboard out. Now this machine is fitting a server cooler. It's very thin. It's designed for server, like 1U or 2U thick boxes. It's really not necessary on this board, on this machine, because yes, there is a board in here, but there should be space for a traditional cooler. My own XT10, yes, I do have my own XT10, of course, I have a projector. I also have my own XT10. I think it has a standard Intel cooler. However, this machine has one peculiarity which makes me think that this type of cooler is probably a good idea. And the peculiarity is that there is no ventilation in this machine. Well, the only fan in this machine is the one in the power supply. There is a ventilation grill here on this side of the chassis, and the air is coming from here through the motherboard and exhausted by the power supply. But as you can imagine, one 80mm fan is not great for a system like this, and with a traditional cooler you probably end up with a pocket of hot air in this corner here, which I think is what exactly happens to my machine, because I think after a few seconds the CPU is reading 80 degrees. So I think as a preventive maintenance I'd like to replace the cooler of this machine. It's a fan, you got bearings in it. This machine was being used 10 hours a day, 7 days a week, so I wouldn't be surprised if this cooler has, I don't know, 50,000 hours on it. I think it's a good idea to replace it. Let's take out the motherboard, we remove the cooler, we'll see what's underneath. Well, the first thing I'm noticing is that the cooler, as you might expect from a very old unit, is completely clogged. Oh well. Well, I got to say, this is an amazing cooler. It's very heavy, it's solid copper, but yeah, the thermal paste is completely dry. Look at this, it's plaster. It's absolutely completely dry, as you'd expect after, what's that, 20 years more or less? Well, not more or less, 20 years. It's absolutely completely dry. So this thing basically was running without cooler, which is not great, right? And this is an Intel Celeron D, 2.66 GHz, and I think 533 MHz of SSP. So again, nothing supersonic. This system is not really about power. All the decoding happens on those extra boards. And the system is fitted with 256 megabytes of RAM. And the battery, as expected, is completely dead, so that will be replaced as well. Well, so the next step is to recap this board. I'm confident that that's going to be our problem, and I only see one type of capacitor which has leaked. But, you know, if this type of capacitor has leaked, all the others, which I believe are the same brand and the same model, they are probably dry inside. They haven't leaked, they haven't exploded, but probably they're not very good inside. We might want to check the first few that we are replacing, but I'm going to replace this anyways. As I said, it's for reliability things, so it's going to work for many years to come. And I see something that looks like liquid, which has dried up and it's been covered by dust over time. So that might be our little clue that all these capacitors have gone. The board is done, we'll test it in a minute, and the capacitors removed from the board, well, most of them were definitely shot. Some capacitors are actually still good. This is the 1500 microfarad and it reads totally fine, the ESR is pretty low. And this is the 1000 microfarad, which again looks totally fine. But the most popular type of capacitor on this board are these 820 microfarad, and those are either bulged or they don't read much anymore. This is one of the slightly bulged capacitor, 820 microfarad is reading picofarads and kilo ohms of ESR, so this is completely gone, it's not a capacitor anymore. This is another of the 820 capacitors, it's reading 15 microfarads, so it's way out of tolerance, and the ESR is 90 ohms, so again, this is not really doing much anymore. However, there are just a few of the 820 which are still reading fine, 763 and 123 milliohms, but most of them have completely gone. But the most critical capacitors on this board, the V-core ones, the ones under the heatsink, they're all gone. This is the best that I can find, 9 microfarad out of 680 and 140 ohms of ESR. The others are completely dead. They have leaked and they're not capacitors anymore. This is reading nanofarads and mega ohms of ESR. So that's probably why the board wasn't starting. Everything else obviously doesn't help, but this is surely the root cause of our fault of the dead motherboard. So the situation should be much better now. Let me put some RAM on this board, the heatsink fresh, thermal paste, wire it into my capture device, and we'll see if it works. Everything is plugged back in, but the battery, simply because I haven't got one, hopefully it's going to start anyways. I know that some older boards don't like running without the battery. We'll give it a go. New capacitors are involved, so you know, just to be on the safe side. Let's power up the power supply. 3, 2, 1, go. Okay, we have a green light in there, and let's start the board. I've got, yeah, there's a beep, postcodes, some beeps. It's doing something, but I haven't got an output. I got 3 beeps, 3 short beeps. I have reseated the memory already quite a few times. Let me try and do this again. And that is lot A1, so I think that should be the default one when you only have one module. No. Now I only have one code, Z0, but the same 3 codes, the same 3 beeps. Okay, I think it's getting worse. Now I haven't got codes. I'm wondering, again, this is, I've seen this before, that crusty slots here prevent everything from working, including the postcard analyzer. Because I had codes before, I didn't capture them on camera, but I definitely had codes. There you go. Okay, so I still have the same 3 beeps. I don't know what that means. I might need to check on the manual or something. I don't know whether this is an AMI or an award bias. Let me look into this. Right, I've just noticed that my OSSC is actually displaying some sort of sync. And I've had this problem before with my capture device where everything gets stuck on that screen, on that gray test button, but actually that's not what the OSSC is outputting. So let me try and remove the HDMI cable and see if the test button goes away. And it does not. I've removed the cable. It's still there. So it's my silly capture device here again. It wouldn't be the first time. It's not going to be the last one. That's when you want to cheap out on things. Right, let's try this again. Do I have a feeling that this is actually working? It's been working over the past 15 minutes. Look at that. It was working all the time. Fatal. Oh, chassis intruded. Yeah, we know about that. I'm not sure exactly how that works. I probably have to short different things, but that's fine. It was working. It was just my bloody capture device. Great, it's working. So we have Celeron D, 266 gigahertz and 256 megabytes of RAM. Great. So let me check how to sort out the chassis intruder connector, and we'll plug a hard drive with test this board, because I'd like to test this board outside of the XT10. The XT10 probably doesn't stress this board a lot. Now, it turned out that shorting those 2 pins on the chassis intrusion jumpers is the right thing to do, but because I started the board before without any jumpers on it, the board recorded an intrusion and it would halt. And the solution was just to get into the BIOS and save it, basically. I've reset the time and date into the BIOS, and I got this compact flash with my MS-DOS connected to it. Let's see if it boots. 3, 2, 1, go. Okay, no errors. And okay, yeah, I think it's in the compact flash, and it's booting. That is so cool. Yes, it's booted. Fantastic. This is working. Now we know what anybody would like to know. Does the DTS XT10 run Doom? It does. I'm sorry, the cooler is very, very noisy, but I think it's very effective. It works pretty well. I'll think of what to do, whether I want to replace it, keep it, lubricate it. Well, the board seems to be working, so I would say let's put it back into the chassis with the DTS boards, and we'll make sure that the system is actually working before moving on to the next steps. Alright, let's start this up and see if we can get any sound out of it. Let's give power to the power supply. 3, 2, 1, go. Yeah, it starts by itself. So I'll flip the switch anyways, and we should be able to see, yes, we see the post. As I said, the front panel is a USB thing, so until the operating system is running, you won't see anything. This should be running Fedora, so I see the hard drive, I see the 2 DVD-ROMs, chassis intruder fatal errors. Okay, so I'll yes, because I removed my jumper to replug the one that comes from DTS, so I think all I need to do is restart get into the BIOS. Actually, I need to power cycle. That's silly design, because if this happens to a cinema, then they need to call someone. I think all I need to do is to save the changes here, and it should work. And it should boot Fedora, because this is running a very old version of Linux. And as I said, the LCD at the front is USB driven, so it won't say anything until some drives have been loaded. Fedora is running, perfect, so the hard drive is still working. We got something on the LCD, so the driver for the LCD has started now. And I think, yes, it's ready, so everything seems to be working. We have this purple screen. In the past, I have accessed like the live console. I can't remember for the life of me. It's quite some time ago. I can't remember exactly how I did it. Now, there is some test content, audio test content of this box, and I basically need to navigate, setup menu, audio, and then audio test. And if I select one of these, it will play the relevant test. There is one little test content I like to run. It's Bill and Buzz Show. It used to be a 35mm reel for demonstrating the DTS. And if I tap enter, it should say DTS playback. Yes, and now we have sound out of this thing. Oh, we got the subtitles on screen. Look at that. So the machine is definitely coming with the subtitle option, because we have them on screen. Those would go on the cinema screen using a small video projector. But we should have sound at the moment. It's just I haven't got anything patched into my capture device. So let me make a custom cable to wire this machine into my 8-channel interface, the Focusrite 18820, which we fixed on this channel. So I can actually show you the 6-channel output of this machine. Fantastic. Oh, first thing first, let me save a backup straight away. There it is, configuration, save on USB. Okay, memory device, please insert USB memory device. Well, it's already there. Well, I think we might have a problem with the USB port. I think one of the pins is bent, and that's why it's not working. I have a feeling that the system is expecting something on this port and nothing else. That's why the ports at the back are not working. No, there we go. Okay, so it just needed to be basically restarted. But this port is not working, so we'll have to fix that as well, which is going to be interesting. I'll have to remove this panel here at the back. And just out of curiosity, let's have a look at what we have saved on these XT10 in terms of movies. So as you can imagine, we have the latest 70mm releases. We have Dune 2, Tenet, another version of Dune 2, Licorice Pizza, Oppenheimer, that was definitely released in 70mm, Vertigo, Loop Test, I don't know, some THX trailers, Joker, 2001 Space Odyssey in 5.1 mix, Dunkirk, Harry Potter and whatever that is, I'm not a massive Harry Potter fan, Inception, Nightmare on Elm Street, Clash of the Titans, Sherlock Holmes, well, Where the Wild Things Are, I think it is. Shorts, I don't know. Harry Potter 6, The Hangover, Gran Torino, Benjamin Button, The Clone Wars, look at that. The Dark Knight, Return of the King, and that's it. So quite a few big releases, as you can imagine. That's why this unit was being used for 70mm or special 35mm releases. Now, to play that sound, I would need the actual film running through the timecode reader, even though I think there might be a way to use SMPTE timecode on this unit. I might want to try that, but I'm not going to play these soundtracks on this channel because of copyright, of course. Alright, it's taken me absolutely forever to wire this thing into my sound interface, get the 5.1 down to stereo and record it with a decent quality. Absolutely forever, a few hours with this jet engine noise in the ears and all sort of issues with Resolve and OBS and Audacity and everything that didn't want to work. But I think I got there. So I'm going to play for you the DTS Flying Disc, the very first DTS trailer that was being played in cinemas. Of course, the XT10 can only do sound, it can't do pictures, so I'll find the video of this trailer online and I'll put it on screen and try to synchronize it a bit. But bear in mind, the video is from somewhere on the internet, the sound is actually coming from this box and it's what exactly was being heard in a cinema back when 35mm was around. And you might have noticed I finally found a way to display the real-time logs on screen. It's just a different console of Linux, so it's Control-Alt-F1, and to display the subtitles, I don't know which one it is, it's another one. This is another console to log in. And here we go, with F7, Control-Alt-F7, we are back to where the subtitles are coming out of the box for the subtitle video projector. And to go back to the logs, Control-Alt-F1, and I see exactly what happens, which is quite useful because you can see whether there's any issues with the soundtracks, with the time code being read by the projector or something. Obviously, that's something that wouldn't normally be available for a projectionist, but it's something if you knew what you were doing, you could plug a VGA monitor and actually monitor these things. I used to monitor my own box, not this one, the previous model, by plugging a VGA card into it and actually see what was happening behind the scenes. It was quite useful to diagnose any problems. So we finally got there, and the next step, before we look into the power supply, the hard drive, and the ventilation of this case, which is absolutely horrendous, I would like to finish the recap of all the other boards. So we're going to take out all the DTS boards, the output, the playback, and the timecode board, and we're going to replace those few capacitors just for reliability purposes. So this device is going to be working for many, many years to come. Right, I think I'd like to share something funny with you. When I inspected the boards and I measured all the capacitors, the SMD capacitors, I noticed that this one says 100 microfarad, 16, so that's 16 volts, and this one says 100, and then there is a JFK. FK is a Panasonic FK series. And Jay, I went online and he said 63 volts. Now I didn't think too much about it, that you don't have 63 volts in a machine like this. But I went ahead and I selected the 100 microfarad JFK, and I thought, okay, I can use this one in here as well. For whatever reason, I didn't check the diameter, and you can see these are way too big. But then I thought, well, 63 volts, that's why they're big, 63 volts, and there's no way I can get 63 volts out of this one. And then I checked on the table online, and this is small j, not big J. I never realized that there is a small and a big. The big J is 63 volts, the small j is 6.3 volts. So, this is way too big, of course. I haven't got any use for that. But thankfully, I have some other 100 microfarad capacitors. I don't know, this is code E. E is 25 volts, so it's plenty for both. And I think I can fit this one on both positions because obviously the voltage is higher for both. And the pads here are enormous, so that's not going to be a problem. So yeah, my 63 volts capacitor here, well, I'd use them for something else, I guess. And when it comes to these capacitors, they're not in a horrible shape, though these are 470 microfarad. They can go down up to 379 and still be in spec, but 399 is kind of on the low side. The other is identical, and the 2200 microfarad is reading 1.8, so that is probably totally fine. When it comes to the SMD ones, I think maybe they were not the greatest quality at the very beginning, because these are 100 microfarad. It's reading 87, so again, just in spec, but it's reading 3.5 ohms. And if I'm checking the ones I'm using, which is, these should be Nichicon CW series, they're not the super best, they're not the Panasonic, but they are pretty good, high quality Nichicon capacitors, and these are reading spot on 100 microfarad and less than 1 ohm, 929 milliohms of ESR. So I guess, again, this is once again 20 years old stuff in an overheating case. You'll see that in a minute. So I think it's just a good idea to replace them all, considering the importance of this box. The fact that if it fails, well, there's going to be quite a lot of people unhappy while watching the movie. Now, this power supply seems to be working totally fine, so I could probably swap the capacitors, swap the fan, and it would be fine. But from a rejuvenation point of view for this box, I think I'd like to replace it, because even if I replace all those components, well, you'd end up with a power supply which has been working for, I don't know, say 50,000 hours. Also, swapping capacitors on those power supplies is usually not easy. They're usually cramped together, covered with that silicone compound. It's not going to be probably super easy. So yes, I'm not going to throw it away. I might reuse it for some projects here. I might want to fix it, rejuvenate it here for other projects. But for the time being, I've got a spare here. I believe that this power supply is a Pentium 4 friendly, which means it's designed for those motherboards which don't have the 12 volts CPU socket. So this is not a big deal for this board because it comes with the 12 volts CPU socket on the board, but I have another XT10 which is a slightly previous, it's not a previous model, it's a previous revision, it has a socket 370 if I remember right, which doesn't come with a 12 volts CPU line that goes to the motherboard. So I might need to pay a little bit of attention on how much current is being drawn by the motherboard and the peripherals to make sure that the power supply I'm using, the replacement one, is a good replacement. And I think I've noticed a peak of about 5 amps while it was booting and doing its stuff. So I'll take a note of that one, say 5 amps. And let's go and check the 5 volts from the ATX connector. And on 5 volts, I see 1 amp being drawn by the motherboard and all these boards connected to the motherboard. And this is the 3.3 volts coming to the motherboard, 4.5 amps. Power going to the output board and this little board here, which should be the automation board. I got 0.17 on the 12 volts line and 0.3 on the 5 volts line. Everything else is the DVD drives, the hard drive. I mean, that's probably a few hundred milliamps. There's nothing to be worried about. So now that I have these measurements, let's take out the power supply and see what it says on the sticker. And then we'll have to talk about ventilation, because this power supply is the only fan in the case. And it's not doing great. This is the power supply. It's a Sparkle Power International Ltd. And it says 250 watts. Now, I've got a replacement here from DigiKey, which is from FSP. And I understand that the S in FSP is Sparkle Power. So these are probably pretty much equivalent. Even they even featured this bracket here at the bottom. And I can see that the cutout at the back is the same. This is a 300 watts power supply. I got the 300 watts intentionally because of what I was saying before. So you'll notice that the 250 watts power supply from DTS, it's 25 amps at 3.3 volts and 25 at 5 volts, while the new one, it's 19 amps at 3.3 and 16 at 5 volts. So that's what we would call a Pentium 4 friendly power supply, while the more modern power supplies, they actually focus the current on 12 volts. You've got 25 amps here, while this one, it's only 13 amps at 12 volts. Now, I believe that this power supply is going to work totally fine on this board because you only have 5 amps at 12 volts, and this can deliver 25. And we have 4.6, let's say 5 amps at 3.3, and this is delivering 19. So that should be totally fine. So I'd be happy to go with this. This also comes with Molex plugs in here rather than, there are a couple of SATA, but I think I have plenty of Molex. 1, 2, 3 Molex. I might need an adapter at some point. I thought I did check. and they were fine. What I'm seeing here, there are a couple of, let's call them setbacks. Now the CPU connector here is 8 pins, while the original one is 4, so I'm hoping that I can just plug half of it. But most importantly, which is quite disappointing, the ATX connector is a 24 pins connector plug, and it's a single piece. And when I ordered it and I realized, oh no, this is 24 and my board is 20, I thought, hey Tony, you didn't check this thing, which I didn't, to be fair. But then I went on the datasheet for this very model on the FSP website through DigiKey. And no, this should have come with a 20 plus 4, which makes totally sense. Why would you manufacture a power supply with a single 24 pins, which basically prevents you from using it on a 20-pin motherboard? So I'm actually in touch with DigiKey. They haven't let me know yet, but clearly there's either a mistake in the datasheet or these power supplies are probably manufactured by someone else, and this one came with the different connector here. And I went to double check the datasheet again, and it's been updated on the FSP website. They basically removed the second page where you could find all the drawings with the connectors, how many connectors he had. It's just shocking that they basically didn't know what they were selling. Honestly, very, very much disappointed by FSP, but it's apparently a decent brand. As you can see, they have no frills, no RGB, no quiet fans or anything, and it's the one with Molex connectors. Everything else nowadays, I guess it comes with SATA and things that I don't need. Let's power them up and compare the fans. Right, unfortunately the FSP power supply is temperature driven, so it's really not running at a reasonable speed. But these also, the original power supply is definitely not running at 12 volts, so this is also temperature driven, I think. This is nothing. It's literally like a little breeze. So I unfortunately have to do a little bit of modifications here. And I've now opened the power supply. This is the brand new one. This is the one that I found in the DTS. And I'm more and more convinced that I don't want to refurbish this one. As you can see, it's very, very busy inside here, and there are quite a few capacitors, including small capacitors on daughter boards, which are going to be quite difficult to replace. Some capacitors are under the heatsink. There's lots of this silicon compound gluing them together. It's going to be absolutely a nightmare. And what was told on Vogons is true. The sparkle is the S in FSP. So there's actually an FSP label on the PCB itself. So this was actually made by FSP. And the brand new one, it's a complete different story. It's very spacious inside here, not many components. I guess that's 20-25 years of technological improvements. Also, I see that the fan is wired to the PCB via a connector. So that's not bad. And also I see a small transistor by the connector, and I believe that this is the one driving the fan. So the transistor is receiving a signal on the base, and then it's driving the fan through the emitter. And we can check this straight away. I'm connected to the positive of the fan, and if I touch the emitter of the transistor, I have continuity, while the collector of the transistor should be wired directly to 12 volts. It is. So all I need to do would be to remove that transistor and then jump the collector and the emitter. Actually, I can put a resistor in between, so I'm not driving the fan exactly at 12 volts. I think like 11 volts is going to be fine. First thing first, I'm going to take the fan out of the case and test it with my power supply. I wanna see how fast it goes. I want to see how powerful it is. There we go. Oh my gosh. Well, the fan is pretty powerful. I'm happy with it. This is running at 12 volts, so we can run it a bit lower voltage. I have to say this fan doesn't really give me a lot of confidence. It's a YL fan D80BH-12. I know it's Yate Loon Electronics. It's very light. It doesn't feel like this is going to run for 100,000 hours, which is what this power supply is. It's not warranted 100,000 hours. The MTBF, the mean time between failures, is rated for. So it's supposed to be like a good quality power supply. The fan is, the airflow is pretty good. That's going to improve the cooling inside the case quite a lot. I would say let's go with this fan for the time being. I'll run it, say 11 volts. Yes, 11 volts seems to be fine. Let me find a resistor that I can put in series and delivers more or less 11 volts to the fan. And I found that a 6 ohm resistor works totally fine. I have 10.9 volts with 12 volts going in, and it's quite chunky, so it doesn't get hot, it doesn't overheat at all. It's only 1 volt. And I think what I'm going to do, I'm going to remove the transistor and basically use the resistor as a little jumper between collector and emitter. Let's do that. Let's test it. Yeah, it's working, and the fan, oh yes. This is gonna make a huge difference with a poor XT10. This is fantastic. Let me order all the adapters and then we'll put it back into the XT10 and we'll test it. Actually, I went ahead and purchased a replacement fan for this power supply. It's a Delta AFB 0812SH. I really like Delta fans. They're high quality, reasonable price, and these has a life expectancy of 70,000 hours at full power. It feels sturdier than the original one, and it should have a higher airflow. Now, the next fan I have to deal with is the CPU cooling fan, and this is a server grade cooler. It's designed for 1U boxes where you haven't got clearance at the top. This is a high quality cooler. It's solid copper, it's really heavy. Also, it's attached to the motherboard with a bracket at the back of the board. It's very small, it's firmly attached to the board, and ideally I'd like to reuse it, because if I want to replace that one with a very similar one, there's one in the UK made by Akaza, it's about £50. Now, these are server graded, so the blowers are rated like 80, 100,000 hours, really high quality, but it's 50 quid. I can buy something with, I think it's like 15 quid, even 10 quid, but they're not the same quality. The fans are nowhere near rated 100,000 hours. They come with the plastic clips. So ideally, I'd like to reuse this one also, because I hate throwing things away. Unfortunately, the blower is not available here in the UK. So I was about to give up, to be honest, and just either buy the 50 quid one or think of something else. And then at some point, I realized that the blower datasheet, which I managed to find online, has the same style of Delta Electronics, the fan manufacturer. So I thought, can I find a fan, not a blower, a fan that fits this footprint here? And I went ahead and I purchased this from DigiKey. It's a Delta fan. It's really high quality, it's really heavy, and it's a 70 by 70. I didn't even know they existed. And I don't know how much you can see that, but it looks like the screw holes, they actually match the existing blower. Now, this is a fan, it's not a blower. Blowers have a much higher air pressure capability, so this is able of sucking air out of the metal fins, the copper fins, so much more than a fan. But this is not a gaming machine. I have plenty of space, and this is like, it's much less pressure, but it's much higher airflow. However, after I ordered this, I think I realized I have some mechanical problems, and I'll have to show you later on when I disassemble the cooler. But before I go ahead and do that, I'd like to do a little bit of experimenting. I'd like to see what kind of CPU temperatures we're getting with this cooler by running Prime 95 maybe. So let me play with the machine, see what kind of temperatures we're getting. And after quite some time running Y Cruncher under Windows XP, I'm not going over 50 degrees, and I think it started from 40, 45. So it looks like the cooler is doing an amazing job. And once again, this is with the CPU running at 100%, which is never going to happen during normal operations. Now let's remove that cooler and let's see what we can do with the fan I purchased. And this is the problem. I completely forgot that obviously being a blower, there's a small cutout here on this metal bracket. So the fan should fit on the other side, but I think the screw holes are exactly there. But obviously I would need to enlarge this hole. And things are getting, I'm trying to save money and also time, because time is money. But now I have to enlarge this one. Now, I don't want to do this straight away. I think it's doable. I have some tools. Let's see what I can do. So before I do any permanent modification, let me just put this back on the system, and I'll just plug the fan on top and see how it performs in terms of temperatures. Well, great news. The system has been running for a while with Y Cruncher, and the CPU temperature hasn't gone above 40 degrees, so this is actually better than the original blower. Also, this fan is creating a little vortex of air around here, which is great because the ventilation in this case is bad, so the more, the better. So the next step is going to be to enlarge this cat out. Let me see what I can come up with, and I'll come back to you. The fan is now blowing down and it's creating this little vortex of air. It's cooling down that should be the north bridge, all the capacitors around this card in here. And with the improved ventilation that we're going to have with the new power supply, all the hot air is going to be sucked away from this direction. So I'm really, really happy. Let's check the temperatures. And it works totally fine. The temperatures are as before, and now we have this extra ventilation here caused by the bigger fan blowing air everywhere. Really, really happy we saved that 350 grams of copper. Now, before we move to the hard drive, I think I'd like to take a look at the DVD drives. I think there's some mechanical issues there. So what seems to be happening is that sometimes the drive doesn't open, but I can see the front panel make some movement. So I'm not sure whether it's a mechanical problem with the belt or that's a different type of mechanical problem. So let me remove this section here, and or maybe just one drive, and we'll take a look. Right, so eventually this will open. I need to find out what's wrong with it. I don't see any like gasket in here, any sticky stuff. Right, the motor is definitely spinning, so I'd be tempted to think it's just a weak belt that just got weak over time. Hello. Oh yes, I think I see... Oh. I think I see the belt is really... Yes, it's very loose. Remove power? Yes. Oh, I think we need new belts. I think it should be a bit more tighter than that. Yeah. I mean, I can... you can see it's 20 years old. It's not very elastic anymore. I remember buying some belts from somewhere at some point. Let me see if I can find some. Yeah, no. Right, it looks like I'll have to place an order. And I couldn't really find match online, including AliExpress. Most of those bunch of belts, they start from 30 millimeters of diameter. This one is around 20. And 20 millimeter is too big, so I'm looking for something smaller than 20, and I really couldn't find much. Also, I don't know how much this shows on camera, but the ones I have from eBay from quite some time ago, I think, they're not the same section of this one. So, the difficulty is to find something which is the right size and also the right section. Now, I did find some pages online where they only sell belts and they have all the sizes I wanted, but for, I would say, extortionate prices. I think one of these belts was around £8, was like $10, which is, I don't know, I'm not prepared to pay that amount of money for one belt for one drive. So I eventually ended up on eBay and I found this product. It's a deck tip part, and it's sold by this company called Mana Tree Products. So they have a quite extensive catalog. This is the 16.5 millimeter diameter and 1.2 square section. And to me, it looks like of excellent quality. That's the original one. This is the one I purchased. This is the one from, say, eBay or AliExpress. The one I had before, the one I had in my stash. It's definitely the right section, and yeah, it's like mildly elastic. And I think it might be the right diameter. Let's test it and see if it works. And I think this is the right belt. Let's power this up and see if it works. Yep. Yes, this is working totally fine. I'm really happy. Looks like a high quality belt, and I would say it's not too expensive. I pay this £3, which is what, about $4, something like that. It's on eBay, plus shipping. So obviously if you only need one, you need to have shipping as well. Well, then maybe this is something that you can consider. I have another belt for the other drive, but first thing first, let's take a look at this one. Now, the drive, it's in excellent shape. So let me clean the optic of this drive, and then we'll do the other one, and then the drives are done, to be honest. Well, it looks like we have the same problem as before. The belt has worn out a bit, has become a bit too loose. So we can try and replace it with exactly the same one that I got for the other one. And now you can see how the two belts compare. I'm really impressed by this little belt. So, well, time will tell whether they are reliable, but it's great that they are reasonably priced, and you can choose from a catalog. So you don't have to buy 50 random belts to then find that the belt that you need is not there. I put the link of the eBay store down below in the description, and now we got, hopefully, 2 working DVD drives, and we can move to the next step. Next is the damaged USB port of the front panel. Let me take the front panel off altogether, and we'll take a look under the microscope. And one of the pins is completely bent at the back of the socket. Now I can try and fix that, but I think I'm going ahead and replace the connector. I'm assuming I can find an identical one, because my concern is that, yes, I can probably kind of fix it and it probably works, but I will never be able to bend that pin back exactly as it was before, and chances are over time it will get caught again by the USB stick and it will bend again. But let me see what I can do anyways. Well, that knot clearly is not going to work, so I thought it was going to be a very simple exercise. Just buy another USB socket, replace it, and happy days. Pretty boring. However, well, this turned into many hours of researching online, trying to find a socket, a USB socket that actually works on this board. Now, for whatever reason, this seems to be a very special USB socket. It's got 1, 2, 3, 4, and 5 legs which connect the shell to the PCB for stability. And that is great, obviously, the more the better. However, I couldn't find anything with 5 legs on the shell or available on like DigiKey, Mouser, RS Components, Farnell. There's nothing available. The best I could find is 3 legs connected to the shell. That's a Molex connector, but it's shorter than this one. Everything else has 2 legs. So after a couple of hours of searching, I decided, okay, it's not going to be the end of the world. I'll go with the 2 legs, and then I'll see what happens. I'll see how stable it is. Worst case scenario, I can maybe patch something up. And this is the replacement I found. It's from DigiKey. I think it's an Adams connector or something like that. And I don't really know whether I will be able to fit the shell legs into the existing holes, but there's a big problem here, which I noticed online. I thought I was being mistaken, but honestly, I don't have any other choice. Now, if I'm lucky, this new connector can only fit this way. It won't be able to fit this way because the existing legs are, say, facing this direction, not this direction. But however, if I manage to fit it this way, I see a problem here. Well, the contacts are reversed. So if I plug it this way, well, all the USB contacts are going to be the other way around. We're going to have 5 volts where ground is supposed to be, ground where 5 volts is going to be, and so on and so forth. As you can see, the shell is not even connected to anything, it's just connected to the PCB itself. And the USB lines are going straight to this connector here. And this connector here is like a fan connector, so worst case scenario, I can just flip it around. But it just doesn't feel right that to replace a USB socket, I have to go through so much hassle. Let me desolder the socket and, well, see what I can do. And the other thing is that the original connector on the left is 16.5 millimeter, and there's nothing available more than 15 millimeters, which is the one I have on the right hand side. It's not the end of the world, but this connector is flush with the XT10 chassis, so it's not ideal to have something slightly shorter, but there's really nothing available. Now, this connector comes from a Japanese company called SMK, and I sent them an email, but they didn't reply, as I would expect. They do have a USB socket in the catalog, but surprisingly it's different. It looks different, it measures differently. So I don't know, for whatever reason DTS decided to choose this weird connector which can't be found anywhere. So in theory this socket would be connected this way, but that's not going to work because if I plug it this way, well, the shell legs are not going to match anything. I might be able to install it this way if I straighten these bent shell legs. Hopefully that's going to work. I need to straighten them up and see what happens. But again, that would also swap the USB signal, so I'll have to take care of that at some point. And no, that doesn't work, as I found from the drawings, the legs are physically in a different place. They're too large. They fit in here, of course, but then the pins end up in the wrong place. So let me start bending things, and failing that, I'll have to solder my own legs somehow, because I can't find anything that just fits plug and play. Right, this is the only way I could think to make it work. It keeps the pin out correctly, and it should be sturdy enough. Once again, there doesn't seem to be any plug-and-play solution. If you do know of a solution, please do let me know down below in the description. Let me put this back on the chassis, and I think the next step would be to fit the brand new hard drive and install the software. The next step is to replace the hard drive as a preventive maintenance and reinstall the software on it. I've selected this Seagate Barracuda 1TB, and this is using a SATA connection. The board, the ASUS, has a SATA port. I'm hoping that the software will like it. You never know, the software might be written to somehow use the PATA port. We'll see what happens. The installation is very simple. This is completely wiped, and I have this install DVD. I just need to power up the unit with the DVD in, and it will ask me if I want to reinstall the software. It will partition, format everything, install the software, and at the end of the process, the software will ask me to load the configuration that we saved at the beginning of the video. This way, you won't have content that is going to be wiped forever, but you're going to have the general configuration, but most importantly, the licenses that came with the DTS, in our case, the subtitle license. Now, you might be asking, why not installing an SSD? SSDs are inexpensive. I don't need 1 terabyte. 500 gigabytes would be okay. It's probably the same price. And we do have a SATA port, so why not that? Well, I thought about that and I decided not to go with the SSD. The reason is the Linux kernel installed in this system doesn't support the trim feature. Now, I'd imagine that this system is going to be fine with an SSD, even without the trim feature, but I don't want to risk it, considering that if something happens to that box, then the sound stops in the auditorium. So, to be on the safe side, I decided not to go with an SSD and to go with a spinning drive. So what do you think about this? Leave a comment down below. I'm really curious because I did ask the question on Vogons and everybody seemed to be pretty much optimistic that it should work. I just don't want to take the risk. So let's plug the drive, let's install the software, and most importantly, well, let's see if it works. So something is not working, the system doesn't like the drives that I sourced, and the installation stops here while it's formatting the content file system, and sometimes it stops at 19%, sometimes 0, sometimes 4, so it's different every time, but it stops every single time. And I fitted an LED to see what the drive is doing. It's definitely stopping doing whatever it's doing. The thing is, I tried 2 different drives. They're both SATA drives. One is 1 terabyte, so it's exactly the same thing. It's the same brand. It's a Seagate, just a bit older, because this one is a bit chunkier. I guess he has a few more platters than the modern one, but this is working totally fine. I tried this one, which is a 500 gigabyte from Hitachi, and this is working totally fine, but this one doesn't work. And I have 2 of them, because I have 2 XT10s. One I'll fix in the future. They both fail, so there's something with this drive. Well, there's something between the motherboard, the drives, the software. I don't know, I wasn't expecting that. I thought it's a SATA drive, it's gonna work. No, something, whatever, it doesn't like it. And now I can't even return them because I've used them. And most importantly, what do I replace them with? Do I try a different brand? But I guess they're gonna be the same. I don't know. I went ahead and purchased this Western Digital drive. If this doesn't work, I really don't know what to do. Woof. Well, this seems to be working, thankfully. I wonder what's wrong with the Seagate ones. And the installation is now complete. And the player is now working totally fine. Now, one last thing I'd like to do is to get rid of this little board. This board plugs into the front panel connector of the motherboard and is responsible for turning on and off the unit. Now, the XT10 is being switched on and off by a rocker switch, which is like this. So it stays on or off depending on which one you're pushing. And despite being an ATX board, so it should have a push button, I guess DTS had wanted a rocker switch. It's probably a simpler behavior for the average user. Now, on the earlier version of the XT10, which is the same unit but with a different motherboard, they just wired the switch in parallel with the power-on pins of the power supply. So by controlling the switch, you were just controlling the power supply, switch on and switch off, and I guess the software is designed to deal with a power cut. Now, with this motherboard, I guess this wasn't working, so they came up with this little contraption here. Now, there is a small microcontroller on this board. It's a PIC, it's a 12F508, and I guess it has a small logic in it just to allow the user to use a rocker switch to turn on and off an ATX board. The PIC is getting 5 volts standby through the intrusion connector, which happens to have a 5 volt standby on it, and then it's connected to the main rocker switch through this wire here, and it should be connected to the power on line of the power supply through this pad here, and that's probably why my unit was not behaving the way I was expecting. Besides that, that is connected to 3 pins on the front panel connector. The power on pin, as you'd expect, the reset line, and 5 volts, the regular 5 volts, through the speaker connector. I didn't even know that one of the pins of the speaker is the regular 5 volts. Now, I don't want to invest too much time on this, but I've been thinking, how can you possibly power on and off a motherboard with a rocker switch? considering that the motherboard is expecting a push button. And what I think is that this PIC is keeping the board onto permanent reset while it's being switched off. So what I think happens when you flip the switch to turn on the XT10 is that the PIC, which is being powered by 5V standby all the time, so it doesn't need the board to run to actually execute its code, it's basically shorting the power on pin of the motherboard to ground and power on the motherboard. Now, when it comes to turn the motherboard off, I really couldn't think of a way to make that happen straight away, because if you're using the power on button on your computer, you have to hold it for 4 seconds to cause a hardware shutdown. So the only way that I can think is that when you turn off the unit using the rocker switch, the logic of the PIC is resetting the board, and immediately after is shorting the power on pins to ground. If you try on your computer, or maybe not your computer, something you don't care about because it's not the greatest thing to do to your computer, if you push the on button while the unit is posting, the motherboard will turn off immediately. At least my computer does that, so I think that's the only way, because otherwise I don't think there is a way, because if you try and control the power supply power on lines, well, those are wired in parallel onto the motherboard, and the motherboard will be trying to drive those lines at the same time, so the switch won't have any effect. In any case, I feel that this is completely unnecessary, as the on line here would be connected to the power on line of the power supply using some clip-on connectors. Now, those connectors, despite being manufactured by 3M, they can't be reliable. They just push on the metal inside the cable on the conductors themselves, and over time, a little bit of oxidation might prevent the unit from turning on and off. So I'm going to replace this with this, which is an identical button, but this time, this is not a rocker switch like this, but it's a push button. So this fits exactly in the same hole, and it will turn and will connect to the power on terminals of the motherboard. This will turn the XT10 into a proper ATX machine, so you push it once and the machine starts. You push it once when Linux is running, and Linux will initiate a soft shutdown, which I think is so much better for the software. So I guess we have all we need to complete these XT10. So let me put everything together, including the power supply, which I haven't tested in the XT10 yet, and I guess then it's time, finally, to thread the film in the projector, run it, and play some DTS sound.